Hello, welcome back. So we are covering probability flipped classroom, and this topic will be on set theory. So set theory is very useful when trying to solve probability questions. So here, for example, is the question representing it in a Venn diagram the sets of 15 students. 8 like Coca-Cola only, 3 like Pepsi, 2 like both, and 2 don't like either. So what we do is when we want to draw a set or your Venn diagram, just draw circles like that. Okay, and the first one here is Coca-Cola. And then this will be Pepsi. Okay, so these are both, at least it's supposed to look like Venn diagrams, but you don't get any extra marks for artwork at all. So you have your two Venn diagrams here, okay? So the first is Coca-Cola only, 8 like Coca-Cola only, 3 like Pepsi only, 2 like both. Okay, so this 2 means that we like 2 students like Coca-Cola and Pepsi, but 8 only like Coca-Cola and 3 only like Pepsi. And then we have 2 that don't like either, so they're outside of the set, right? So if we add those up, then we will have 8, 2, 3, and 2, and that's 2, 5, 7, 15. They all add up to 15, and that's what's called the universal. Then all of them together is equal to 15. So here's an example here that we'll do again in set theory probability. So representing a Venn diagram the sets of 15 students. 7 like PS5 only, 3 like Microsoft Xbox only, 3 like both, and 2 not like either. So now I want you to just pause the video and try this yourself. Okay, so the solution to this then, okay, if you haven't done this, make sure you hit pause. If you have this done, then continue. So we get our two Venn diagrams here. Okay, so we have PS5 here, PS5, and we have the Xbox here. So universal U is equal to 15. That means the total number of students that we have. 7 like PS5 only, so 7 goes in here. 3 like Xbox only, so 3 go here. 3 like both, and 2 like neither. Okay, now sometimes as well you might have a kind of rectangle like this, or a grid, just to kind of space it out. So 7 plus 3 is 10, plus 3 is 13, and 2 is 15, and that's your solution. So here's an example of two sets that we have here, okay, and people were surveyed. What did it before? Was it Nike, Adidas, or both? Okay, so I have a number of questions here. So at this point then you can pause and you can attempt to answer these questions, okay? So if you finish questions then, I'll continue and answer them. So determine how many adults like Nike and Adidas. Okay, so what we do here is, I can see here that Nike and Adidas, well, it would have to be an intersection then, because it'd have to like both of them. So 25 only like Nike, 15 like only Adidas, but we have 5. So the answer there is equal to 5. Okay. Determine how many adults like Nike or Adidas. So or, that means they can either or. So, and that you be very careful here, that it can include both as well. So that's 25 plus 15, which is 40, and add your 5, and that is 45. Okay, so that's 25 plus 15 plus 5, and that's added, that gives you 45. How many don't like Nike? Now be very careful here. Sometimes people will just go, yeah, it's 5 and 15, but you have to remember there's 15 outside that don't like either Nike or Adidas. So just be careful there. So don't like Nike, we have 5. Sorry, my mistake. This 5 do obviously like Nike because they like both of them, but 15 don't like Nike, they only like Adidas, and 15 like don't like either. So that's 30. How many don't like Adidas? So similarly again, you have this 5 and 15 that do like Adidas, but this 25 and 15 don't. 25 only like Nike, and you 15 that don't like either. That's 40. Many people in total. So when you get a Venn diagram like this, or your sets, you add them all, and be very careful to make sure you add in those outside of the Venn diagram as well. So we have 25. Make sure you use a calculator as well when you're doing this. 25 plus 5 plus 15 plus 15. Okay, so that's 30, that's 55, that's 16 total. 16 total. So another concept that's important in here is what's called mutually exclusive. So mutually exclusive events have no elements or outcomes in common. This means that both events cannot happen at the same time. For example, you cannot get heads and tails when you flick a coin. So if you flick it once, you either get heads or tails. Two events are said to be exclusive if their intersection is empty. So for example, just say if I flick the coin, just say 100 times, okay, and this is heads here and this is tails. So heads, tails. Okay, so what I could have gotten just say 60 heads, 40 tails. You can't get anything in the intersection. Therefore, your intersection, if it's empty like this, the events are said to be mutually exclusive. So many thanks for watching the video. Remember, you can watch these videos as many times as you like, and we will use these concepts today that we learned and put them into practice into different active learning methods and student-centered methods in the classroom. Thank you.